Hi Math 8 students, today we're looking at more Pythagorean's theorem problems. Use Pythagorean's theorem to find the length of the missing leg of each right triangle to the nearest tenth of a unit. Let's do the odds together. So yesterday we used Pythagorean's theorem to find the length of the missing hypotenuse. Today we're using it to find the length of a missing leg. So it's going to be a little bit different than what we've seen in the past. So for this first example, we have 5 is a missing leg, and it looks like it's the smaller of the two, so I'm going to call this side A, this side B, and this has to be C because it's opposite of the right angle. So now we have A squared plus B squared equals C squared, our famous Pythagorean's theorem. We plug in 5 for A, we leave B because that's what we need to solve for, and we plug in 13 for C. Now, 5 squared is 25, and 13 squared is 169. So now, since I need to solve for B, I need to start by taking away 25 first, just like I'm solving an equation. So now B squared equals 144. And then lastly, we take the square root, and B equals 12 or negative 12. But because we're finding the length of a side, it's just positive 12. All right, let's try another. So for 3, we have A is 6, B is not known, and C is 18. So again, A squared plus B squared equals C squared gives us 6 squared plus B squared equals 18 squared. 6 squared is 36 plus B squared equals 18 squared, which is 324. We subtract the 36 to get the B squared by itself, and we get B squared equals 11 minus 3 is 8, 288. And we take the square root to get the B by itself. Now, 288 is definitely not a perfect square I'm aware of, so I'm assuming we're going to have to estimate here. We use our calculator, and we do 288 square root. Rounding to the nearest tenth, we get 16.97, and the 7 requires us to move up. But that makes the 9 a 10, so this is going to be about 17.0. Okay, and because it said to round to the nearest tenth, we're going to put that 0.0 because that's the tenths place, and 17 is not the exact answer. And if you remember, 289 is actually a perfect square, and that's 17 by 17, so that's why our answer is almost 17. All right, let's try another. Number 5. Here we have A is 9, B unknown, and C is 14. So A squared plus B squared equals C squared gives us 9 squared plus B squared equals 14 squared. We know 9 squared is 81. We keep the B squared, and 14 squared is 196. Subtract the 81 from both sides. We get B squared equals 115. Then we take the square root, and I'm pretty sure you're aware that is not a perfect square, so we're going to assume that we're rounding to the nearest tenth here. We pull out our calculator. 115 square root is 10.72. No need to round up, so it's about 10.7. All right, let's see what else we've got. Number 7. So now in this case, the A is missing, B is 24, and C is 25. So we have A squared plus B squared equals C squared. We leave the A squared plus 24 squared equals 25 squared. Leaving the A squared, we get 24 squared is 576, and 25 squared is 625. Now, I've been doing this math for a really long time, so I know those numbers by heart. Again, if you don't, that's okay. Just use your calculator and do 24 squared and 25 squared. So now we subtract the 576. And we get a squared equals 625 minus 576, which means we have to borrow. And 15 minus 6 is 9. Borrowing again. 11 minus 7 is 4. And 5 minus 5 cancels out. So it's a squared equals 49. Take the square root, and we know that 49 is a perfect square with the answers of 7 and negative 7. But because this is a triangle and a side length, we just need 7. So a equals 7. Let's see what else we've got in store for you. Oh, a word problem. So for the problems below, you're going to draw a picture that represents the scenario, and then we're going to use Pythagorean's theorem to find the answer. So for this one, we have a 15-foot ladder and need to reach exactly 9 feet up the wall. How far away from the wall should you place the ladder so that you can reach your desired location? Okay, so the wall has to be 9 feet because that's how far we need to reach. And then the ladder is placed a certain distance away from the wall. So the wall and the floor make our right angle, and our ladder is the hypotenuse, which makes sense because the ladder wouldn't be leaning straight up and down or right on the floor. It would be at the diagonal. So this is our 15 feet, and we need to solve for what looks like the smaller side, so I'm going to say it's A. Now, if you put it as B, that's totally fine as well. So we have a squared plus b squared equals c squared. In this case, we have a squared plus 9 squared equals 15 squared. The a squared stays, and we know that 9 squared is 81. And we know that 15 squared is 225. So we subtract 81, leaving us with a squared equals 5 minus 1 is 4, and 22 minus 8 is 14. So it's 144, which is a perfect square. So we get A equals 12 feet in this case. Important to put the unit because it's a word problem. So this is actually 12 feet down here. And 9, 12, and 15 make the right triangle that's formed by the ladder leaning against the wall. All right, let's try another. Number 11. A barn roof covers a span that is 32 feet across. The peak of the roof is 23 feet above the walls. Find the length of each side of the slanted roof. Okay, so it covers a span of 32 feet across. Now, when I think of a barn roof, I think of something that looks like this. And here's the barn underneath it with the doors. So something like this is what you should be picturing. And again, it says it's 32 feet across, so this would be our 32 feet. And it has a height, or the peak, is 23 feet above the walls. So this is 23 feet. Okay, so before we really do any work here, we have to think about this, because this is not a right triangle with the 32 feet and the 23 feet. But if I consider this as being a right angle here, then this part is a right triangle. So the height is 23, but the length of this bottom of that right triangle is not 32. It would be half the distance across, so it would be 16. And we're looking to find C, which is actually the hypotenuse, not one of the legs. So we're going to do, again, a squared plus b squared equals c squared, which gives us 16 squared plus 23 squared equals c squared. And I know 16 squared is 256, but I don't know 23 squared, so I'm going to use my calculator. And 23 squared is 529 equals c squared. Adding that up, 6 and 9 is 15, carry the 1. 5 and 2 is 7, plus 1 more is 8. and 2 and 5 is 7. So we get 785 equals c squared, and we take the square root. Now, I'm not sure if 785 is a perfect square or not, so I'll wait to put my sign. I do 785 square root, and I get 28.01. So we're going to round that to about 28.0. So C is approximately 28.0, and feet is our unit. All right, so with the word problems, it can be a little bit tricky, and sometimes you have to pay really close attention to the details to make sure that in a case like this, you don't just start plugging the numbers into the equation. You have to really think about what side is missing and what you're solving for. All right, so from here, you guys are on your own. You're going to try all the evens. I'll be around to help you guys out. Good luck.